Chapter 19, slides 7 through 11. Now, for this portion of slides, we're going to focus on all of the chemistry that we've actually already done, where ketones and aldehydes are our starting material, and we're going to react them with a nucleophile. So this is I call these explosion charts. If you direct your eye to the middle, this is our starting aldehyde or ketone, okay? So we're going to learn quite a few reactions, but rest assured, some of these we've already seen before. So this section of slides are going to focus on the review reactions. Now, the 1,2 additions that we've seen, I want to reiterate the in, up, down, out mechanism of them. We're going to start with a ketone or an aldehyde. That means that both R and Q are a carbon or a hydrogen. The review chemistry for ketones and aldehydes has the nucleophile also being a carbon or a hydrogen. Okay, this is important. So R is a carbon or a hydrogen, Q is a carbon or a hydrogen, and the nucleophile is a carbon or a hydrogen. What this means is that we are going to follow this route right here. We're going to go in and up, but that O- gets stuck right here. And there's nowhere for it to go other than just to work it up with some acid-base chemistry. Here's an example. I could give you this aldehyde. Notice that the carbonyl is flanked by a carbon and a hydrogen. And if I were to react it with a Grignard, say ethyl magnesium bromide, you recall that magnesium is 2+, bromine is 1-, the carbon it's attached to is also 1-. So really, this is just a carbon nucleophile. The carbon has a lone pair, and it attacks in an in-up fashion. In, up. The oxygen has the negative charge. And now when you evaluate, you have carbon, carbon, hydrogen. I used a carbon to attack a carbonyl that already was flanked by carbons and hydrogens. So therefore, you're not going to be able to do down and out. We're stuck. There's nothing left to do but an acid-base workup. Okay, so we're going to add an acid to quench the O- and call it a day. We've just made an alcohol. Let's number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The alcohol is at 4, and I don't have to draw the hydrogen on carbon 4. So this is my final product. We have now just covered a Grignard. Okay, so we've seen those before, and we can do that on ketones or aldehydes. They work the same exact way. We also can use hydride nucleophiles to reduce carbonyls. So again, let's start with, let's say this ketone, cyclohexanone. And let's say that I reacted it with lithium borohydride. The boron, remember, has 4 hydrogens around it, making it outside of its bond trend, and the counter ion is lithium. In solution, the boron would like to get rid of one of those hydrogens as an H-. So if you just recognize this as an H- source, you can shorten the mechanism. The mechanism, again, is a 1,2 addition. Notice that we start with a carbonyl flanked by carbons, making it a ketone, and the nucleophile is an H-. So again, I'm dealing with nothing but carbons and hydrogens. So the hydride, which has 2 electrons, attacks in and up. And then you evaluate. Carbon, carbon, hydrogen. Nope, I cannot come down and out. I'm stuck. So there's nothing left to do but an acid-base workup. So I'm going to add a little bit of acid to quench the O-. And I end with the alcohol. I don't have to draw the other hydrogen that I just added because those are assumed to be there. So I can neaten up my final product. We have now just looked at the hydride scenario leading to alcohols. Can be done on both ketones and aldehydes. So that's our review. We've seen these before. In and up follows the trend. Here's one for you to try using old chemistry you've seen in the past.